This presentation is on chapter 12 in the book on OS security. In computing, operating system hardening is usually the process of securing a system by reducing its surface of vulnerability. A system has a larger vulnerability surface the more that it does. In principle, a single function system is more secure than a multi-purpose one. And that kind of makes sense. Reducing available vectors of attack typically includes the removal of unnecessary software, which would also include you also want to include unnecessary username or logins and the disabling or removal of unnecessary services. For anyone that has been an admin, an IT admin at any level, regardless if it's for a lab, an organization, a business, whatever the case may be, this makes a lot of sense. This is what a very basic principle that they'll do. Also, system hardening is a step-by-step process of securely configuring a system to protect it against unauthorized access, while taking steps to make the system more reliable. In essence, anything that is done to harden your system will ensure that the system is both secure and reliable. System hardening is extremely important and necessary because most OSs that are out of the box, they are designed primarily to be easy to use rather than secure. Now, most of these systems can have security measures enabled that would make them suitable for high security and high reliability environments, but that's not in all cases. So you have to know what OS you're working with, and you still need to have, and we're going to talk about this in the next slide, but a policy that walks you through, a process that walks you through how you harden your OS, even if that OS has built-in capabilities or if it doesn't. So here's an example checklist for hardening an OS. Two things to note here. This list is not complete. And secondly, this list is OS specific. This one is for, I think, a Windows box that's designed to be a server. This would be much different for a client, a Win client workstation, or a Linux box or a Mac. So you have to make sure you grab the right checklist, or at least have the right one in place for the OS you're working with. So you see in this example, the first step is to prepare and install. And again, if you guys have done any of this, this stuff makes a lot of sense. In fact, this might be, I think at this point in the semester, this may make the most sense because we talked about the importance of protecting your system and how easy it is for people to get into your system. So these are very straightforward measures you can take to harden your system. So the first one is to, if you're doing a new install, you want to protect it from hostile network traffic until your OS is installed and hardened. In an organization, it is better to, regardless if it's an organization or not, it's better to install your OS while it's offline if that's possible. And if it's online, make sure it's not connected to your main network. You should have a secure network and you want to connect it there. I would encourage you to use a security configuration wizard that accompanies most OSs to harden that host client. Another thing when it comes to service packs and hotfixes, you always want to install the latest service packs and hotfixes. Again, this is a Microsoft box, so you always want to install the latest Microsoft patches. And you also want to enable the automatic notification of when new patches are available. For auditing and account policies, again, a lot of this stuff is straightforward. You want to configure your audit policy as described in your organization, by your organization. You want to set the minimum password length. You want to enable password complexity, and you want to configure event log settings. So these are just some of the steps you have to do in this checklist to harden your OS. And again, this list is not complete, and it's specific to a particular Microsoft Windows box. Now this is more of a generic example, or a generic list of some of the major milestones in OS hardening, because this is now independent of what platform or what OS you're using. And again, a lot of the stuff is going to be very straightforward. If you already work for an organization, they should already have this in place. If not, I would strongly encourage you to talk to whoever the decision makers are and get this in place. First thing is to disconnect from the network, as I said before. Then you want to install from a trusted source, usually a CD or DVD. Do not install from the internet. Yeah, that is the easiest way to get malware. And again, I think that's pretty straightforward by now. If you have to install patches, make sure try to do it offline. And if you're going to install applications, which you will, try to do that offline. You want to follow CIS benchmark, and that stuff is available, freely available. Just do an internet search, a Google search, and more likely your organization, if you're employed by an organization, they will already have benchmarks for you. You also want to disable or restrict services, and the benchmarks will help to determine which ones that should be disabled and or restricted. And you want to configure periodic updates accordingly. So again, if we map this back to the Microsoft checklist, we install from offline. We install everything from offline. So we install the OS when it's disconnected from the network, and then we install the applications, the software, the patches offline, and then we have to configure our updates correctly so that we're always getting automatic updates. So again, these are just major milestones. This is not a complete list. If you're in a job where this matters, to make sure that you guys have a complete list, and you need to follow this list. It's a time-consuming process, but it's a very important process. The book goes on to mention application security, and we'll walk through what the components of application security is. So let's start with the first one. For input validation, this is where you're requiring your users to put something into the system. Usually it's going to be their user login and authentication of credentials. It could be other things as well. But you want to make sure that the input your application receives is valid and safe. So input validation refers to how your application filters, scrubs, or rejects inputs before additional processing. If you can recall, we talked about this in chapter 11 with handling SQL injections or just injections in general, on how to filter or escape to make sure you're not allowing that command to enter your database and do some bad things to your application or your data. Secondly, authentication. This is the process where an entity proves the identity of another entity, typically through credentials such as a username and password. We talked about this much earlier in the semester. This should be pretty straightforward. The next one, another one that should be pretty straightforward, is authorization. This is where you tell your this is where the system defines what the user can access and the operations they can perform. So this is after they've been authenticated. They should have access rights, and these access rights or controls should be limited based upon what their needs are, and it will determine what kind of controls they have for resources and operations. Next one is configuration management. This is where, for configuration management, this is where you determine how your application runs, which databases will it connect to, how is it administered, and how are these settings secured. So configuration management refers to how your application handles these operational issues. The next one is sensitive data. This refers to how your application handles any data that must be protected either in memory, over the wire, or in persistent stores. Nowadays, that matters because with Google Play or Android and the Mac Store, you want to make sure that data is handled correctly. Another one is session management. A session refers to a series of related interactions between a user and your web application. Session management defines or determines how your application will handle and protect these interactions. Another one is cryptography. We talked about cryptography, I think chapter 1 or chapter 2. What cryptography entails, it's determining how you're keeping your secrets. You want to make sure your data and your libraries are tamper-proof, and then you also want to provide seeds for random values so that your cryptography is strong. This refers to how your application enforces confidentiality and integrity. These are two different legs of the CIA triangle that we talked about way back at the very beginning. The next one is parameter manipulation. These are forms and fields, query string arguments, and cookie values that are frequently used as parameters for your application. Parameter manipulation refers to both how your application safeguards tampering of these values and how your application process these input parameters. The next one is exception management. Exception management is where when you have a method call in your application that fails, what does your application do? How much do you reveal? Do you return friendly error information to end users? Do you pass valuable exception information back to the caller? Does your application fail gracefully? So when you tie that with proper software practices, hopefully you're doing exception management correctly. Now for security maintenance, I'm not going to spend too much time on this slide. I think by now, even if you guys were newbies coming into cybersecurity, by this 12th week, this stuff would make a lot of sense. More likely, most of you guys have come in with experience. You guys are already doing these things, so it's not. It's almost like I'm preaching to the choir right now. But for security maintenance, these are the 4 things you guys should be doing. At least components you should have some type of implementation policy for. So that's logging. We kind of talked about that earlier. Performing regular backups. Being able to recover from security compromises, and you want to be able to test your system on a regular basis. So again, more likely you guys, this should make a lot of sense to everybody right now. And if not, you may want to go back to figure out what these things mean or ask me offline. Now the book talks about some best practices for Linux and Unix security. So in order to understand this, first thing you want to do is you don't want to enable services that can be attacked from the outside. Let me say it differently. Services that are disabled cannot be attacked from the outside. So if you don't provide access to a service, it doesn't matter if there are any vulnerabilities in the process that it's running, because no one from the outside can get to it. So the point of that is you want to disable anything you do not need to use. Secondly, some processes are started when the system boots and remains active as long as the system remains up. For these persistent demons, you need to look at the initialization scripts or programs used to start services when the system boots. Other services are not started at boot time, but instead are managed either by other processes, so you want to make sure, and that's going to be defined in your configuration files. Now for in Linux, you can actually use something called IP tables or IP chains. This is where you get to define whose IP addresses you will accept or reject. The rules can be different for incoming and outgoing packets as well. Now, SSH, so that's Secured Shell, is a protocol which supports logging into a remote system or executing commands on a remote system using an encrypted communication between the two systems. Session encryption protects you from unscrupulous packet sniffers who may have access to one of the networks. Let's see here. The other one is Unix file sharing. This is where you may want to give others access to your directory files and one of your directories. So as an individual user, you can control who has access to the files which you own by setting Unix file permissions. We talked about that at some level, where the read-write and read-write commands at the user, the owner, group, and the world. You want to make sure you set those correctly. And the last one is practices for Windows. So in both cases, patches are definitely important. In Windows, it seems to be something that's stressed more. Now, so you guys should know by now that a patch is a security update which is designed to fix vulnerabilities in applications and plugins. So patch management is a strategy and process used to determine what patches should be applied to which applications and when. So implementing patch management best practices should be tactical, integrated, and an automated approach to handling vulnerabilities. In doing that correctly, you'll be able to boost your internet security, your network security, and endpoint security. In a lot of cases, proper patch management will help you with security audits and compliance audits. So patch management is very important. Additionally, user admin and access controls. We've talked about this several times now. You want to make sure you have the right privileges to the people and give them proper access. It's always better to give them the least amount of access and have them move forward in that direction. And last one is application and service configuration. This is where programmers and system admins will want to use service configuration programs to modify or query the database of installed services. The database can also be accessed by using the registry function. However, you really should only use the security or service configuration management functions to ensure that the service is properly installed and configured. So you want to bypass having people use registry instead of having them use the service configuration management tool, or you guys may know that as the SCM. So the SCM functions require either a handle to a SC manager object or to a handle to a service object. And to obtain these handles, the service configuration program has to do a few requirements, and depending upon what you're trying to do, you want to make sure you understand what those requirements are. So that ends this presentation. So hopefully by now you have a good understanding of how to harden your OS and some of the best practices for a Linux box as well as a Windows box.